You can also graph the solution set of a system of linear inequalities when they both have two unknown variables. So the way you would do this is just like if you're looking at a single one by graphing it, and do that for each and create equations here for each and find the ordered pairs. So this one down here, we know that when x is 4, this would be 4, this would have to be 0. And let's just start from the y. It seems easier for the y because all we'd have to do is plus it to the other side. Let's say this is 1, this would have to be 5, this is 2, and this would be 6. For this one, we know that when y is 1, this would have to be -4. If this is 2, this is -5, and so on. Now that we have 3 ordered pairs, let's go ahead and graph them. So this first one right here, it will be 4 and 0. So 4 out, and 0 up or down. Second one is 5 and 1, 5 and 1, and then the last one was 6 and 3. So that's our first one. To complete the graphing, you have to remember to look up here and look at this sign. If it didn't have this underscore right here, and it was just a less than sign, we would do a dash for the line. But in this case, we want a solid line because it does have the underscore there. So go ahead and just draw in a solid line. Okay, and that would extend on. And now if you've done that, we're going to continue on with this one and just test each side of it. Actually, let's look back at here. Just each side, because there are, like you remembered, there are ordered pairs that satisfy the inequality and ones that don't. And we need to figure out on which side of this line is the area that contains the satisfying ordered pairs. So let's just choose one. So 1, 1. It's this one right here. 1. Sounds good. How about -3 for y and 3 for x? There's another one. So let's test those two and we'll figure out which one will shade. Remember, back up to, we're going to use this original equation here. So first one is 1, 1. So 1, 1 is less than 4. That means that 0, okay, this will become 0 is less than or equal to 4. That's true. And you could go ahead and plug this one in as well to figure out and to check if this comes out false in that inequality, then that's just the way to double check it. It seems that as we've already figured out which side is true, let's just go ahead and we're going to mark, we'll go ahead and shade the top portion because this is the one with the ordered pairs. So just a little bit, I'm not going to color too much in here, just for time's sake. But you get the idea. That's going to be the half that has our ordered pairs that satisfy the inequality. Now for the second one, we have to graph this second inequality here. So -4 for x, and then up 1. -4, up 1. Then we have -5 up to, and then the last one is right here. And if you remember, it also had an underscore for its symbol, so we're going to write a solid line. Okay, so now we need to figure out which side down below here or up above that line has the solution set that satisfies our inequality. So let's just choose a point. We can use 1, 1 again because that's an easy one, and that's above it. So I'll be for the top side. And then the bottom one, let's go -5, -5. That's easy enough to write. Okay. So let's go back up here. Remember to look at this one right here. So first it was 1 and 1. 1 plus 1 is less than or equal to -3. And that becomes 2, -3. That's a false statement. That's not true. So what we figured out with that is that this bottom half is false and does not have the solution set. So that would mean top half is true. And just to verify that, let's just put in 1 and 1. Or in fact, actually, the top half was the false side, looking back at the numbers, because we did put in 1 and 1. So the top half here is false. This must be true, but we can verify that by putting in the -5, -5. So remember this equation? I'll write it just below it. So it's -5, -5. And that is -10. And that's true. -10 is less than or equal to -3. So the bottom half gets the shading. Okay, so now what we figured out is that with both of these inequalities, when we graph them, they have specific solution sets, and they actually have an intersection point where both of them share the same solution sets or ordered pairs that will satisfy both inequalities. So let's just put in a different color, a little red in there, just to show that this is an overlap. And this is what you would call the intersection of both of those solution sets. And if you were to look at all the shaded area, that's the union. So now you figured out how to graph solution sets to two different inequalities and find the intersection and the union for both of them.